Very good morning. Welcome to YouTube channel. So this is the class 5. Today I take the topic the splitting field and degree of extension. The very interesting topic one. We know very well. Whatever it is in competitive examination, national level conducted by CSIR, then JEE. Very useful video. Please listen. I try my level best to explain this concept. Let E be an extension field of field F, capital F. The F is the field extension E, and I take one element belong E. We call algebraic over F. When we can call if A is the zero of some non-zero polynomial. If I take A is the non-zero polynomial, then you can say algebraic over F. Next, if A is not algebraic over F, it is called, you can say it is a transcendental. We know very well the transcendental number. The transcendental number is E, for example, right? E is a transcendental number. So this is algebraic number, this is a transcendental number. An extension E of F is called an algebraic extension of F. When we can say it's algebraic extension, every element in E is algebraic over F. Suppose E is not an algebraic extension of F, we can say that is a transcendental extension of F. That one is algebraic extension of F. This one is not an algebraic extension. We can say transcendental extension of F. An extension of F of the form F of A is called a simple extension of F. So this is called a simple extension because the single element A extended. So it's a simple extension of F. The next important one, the degree of an extension. Let E be a field extension of a field F. From F, the field is extend to E. So it's an extension of F. As degree n over F, and you can say right, E is the extension of, this is a notation, this is a symbol, this is a, I'm right, this is in the most of the books, this is a Gallian and an string using this symbol. So here the F is a field, is the extension of F, then which is equal to n. So there is a degree. Suppose a degree is finite, is called a finite extension. Right? N, we know the n value, that is called the finite extension of F. Otherwise, E is an infinite extension of F. We know n is finite, that is called finite extension. Suppose n is infinite, that is an infinite extension of F. I think you can understand, I believe. I hope everyone, I think, understand. For example, I take this one. The set of the polynomial with the coefficient, the Z is notation integers. So I take the polynomial, collect the polynomials from this, the P, where P is the prime, the polynomial coefficients from ZP. It's a vector space over ZP, where P is here the prime. So this is the field, the moreover the collection of the polynomials. So I take one polynomial x square plus 1. Okay. So from this, you can extend at q, that is rationals. Then you can extend the real, right? But I take the polynomial here, x square plus 1, where the polynomial splits. Where the polynomial splits. That is very important, am I right? So I take here x square plus 1 from the extended rational q of the collection of polynomial, then q of x. Here x square plus 1 does not split. Am I right? X square plus 1 does not split. We can't factorize here also. Am I right? We can't factorize. We did not get the roots. So does not split. Next again, reals. I take reals. Here also does not split. What about the next extension? That is a complex field. Before the complex field, you get the I, the q of I. It's a splitting field. There is q of I. Here, the f of x splits, right? Splits C. So q of I is a splitting field. So here only the splits the field. So here f of x is called the splitting field. That is q of I. So finally, hence f of x equal to x square plus 1 splits in C. I hope everyone understand, I think. So this diagram is more than enough, I think so. So Q is a field F, then extension C. So this is the F, this is the extension E. In between, we are getting the smallest, it is a very smallest extension, Q of I. This one. The smallest extension, this one. So it's called a splitting field. This is also extension, which is the smallest extension. The basis is 1, I. We know very well the basis. Suppose or extend to C here degree 2. How we can say degree 2? Because the basis is 1, I. We know using this form. Am I right? So 1, I is a basis. This basis is enough to extend to the complex field. This is a rational. So I take this a polynomial here. This polynomial split in the C. So Q of I is a splitting field. Now you can see, you can easily understand. Now the elements in base is 2, that's why the degree is 2. The splitting field over Q is next I consider x square plus 1 in Q of x. You can factorize like this: x plus root of minus 1, x minus root of minus 1. You know very well root of minus 1 is nothing but I. Now f of x split in C, so Q of I is a splitting field. Now we take the first problem. This type of question asks several times in CSIR, national level, competitive examination in subject of mathematics. The first problem, the splitting field of x cube minus 2 over q is, the 4 options are given, the well known. So how to get the splitting field? The given polynomial is 1, x cube minus 2, the rationals. To find the roots, So that's why you take equal to 0. From this you can get x equal to power 1 by 3 and 1 power 1 by 3. We know very well this is the cube root of unity. That is 1 omega square. We know the omega about that. So omega, which is equal to minus 1 plus or minus I root 3 by 2. That is 2 power 1 by 3 into this one and this and this. We are getting the 3 roots. Right. So how to get the splitting field now? So x having the roots like this. So Q, that is a field. 2 here 2 power 1 by 3. That is one of the root omega. Omega square also is there. Through omega you can generate this one. So this is enough. So 2 power 1 by 3 omega is our required splitting field. This can be written as like this. 2 power 1 by 3, that is the cube root of 2 equal to omega is a splitting field. So this is our answer. So option C is correct. Right. Answer C is absolutely correct. The remaining option. Okay. We know very well this one. X cube minus 1 equal to 0, x cube equal to 1 cube root. That is solved using the minus b plus or minus root of b square minus 4ac by 2a formula. Use this one. You can take this. So this omega is enough. We take this omega. We know this, everyone about this concept. So that's why we take only omega. So cube root of 2, then omega is enough. This is called splitting field. I hope everyone understand this problem 1. Simply for take this one, everyone, this all the steps. Just go through this one. So there are 3 roots. There is a cube root of unity, already well known. Everyone, this one. Well known this one. Everyone should know about this. I know very well. Our aim is next to find the degree. But in the question asking only splitting field, by interesting we are going to find the degree. How to find the degree? So for that, x cube equal to 2, x equal to 2 power 1 by 3 into 1 power 1 by 3. We know that is a root of, that is a 0 of this polynomial. That is a minimal polynomial whose degree is 3. Right? So degree 3. This is a root of the minimal polynomial of this. So whose degree is 3. So what about this? Just now we have seen it's a root of x cube minus 1. So what about the minimal polynomial? But we know the minimal x square plus x plus 1, which is a minimal polynomial, is also satisfied. So whose degree is 2. So I take 2. So here I take 3, here I take 2. So immediately from this we are getting the degree, minimal polynomial degree 3. From this we get the minimal polynomial degree 2. So 3 into 2, 6. So this is the degree. Alright. The given Q, that is F, I take extension, that is R. So we are getting the degree 6. Next interesting problem, second one, the degree of the splitting field of x square plus x plus 1 over q. The 4 options are given. So we will find which one is the correct solution. X square plus x plus 1 equal to 0. I take, because we have to find out the degree. For that, just now we have seen this one. So omega this, right? So which is the minimal polynomial whose degree is 2. So the answer is 2. So everyone is I hope to understand very well. So the option B is correct, the remaining is wrong. Next, third one. One more interesting problem. I am going to find out the splitting field and root. As usual, the steps x square plus 3 equal to 0. The as usual steps we are following. We know very well, everyone. Is equal to root 3, root of minus 1. So this is our required splitting field, am I right? Root 3. And this become, we know very well, plus or minus I. We take only I is enough, more than enough. So that is a q of root 3 comma I is a splitting field. X square plus 3. This can be factors like this, x plus root of minus 3, x minus root of minus 3. So root 3, well known, this root 3 is a root of x square minus 3, which is the minimal polynomial whose degree is 2. Right, whose degree is 2. I is a root of x minus also is enough. Right. I is the 0 of this polynomial. This polynomial is the minimal polynomial whose degree is 1. So 2 into 1. So 2. So what about the degree of this one? 2. What is the splitting field? This one, q of root 3 comma I. The splitting field degree is 2. I hope this problem. Next very interesting one, the fourth one. A square minus 2, a square minus 3. Rational. The same steps we are going to following. Equal to 0, then x square minus 2. These are all steps. The well known. So finally root 2 plus or minus root 2. We take only root 2 as enough. Plus or minus root 3. Enough, root 3 only is enough. So what is the splitting field? Q of root 2 comma root 3 is a splitting field. Right. This polynomial splits here. So it is a splitting field. So how to find the degree? We know very well. What is a root? Roots are a root 2, root 3. Root 2 is a root of, what is the minimal polynomial? So to satisfy this, x square minus 2, am I right? What is the degree of this? 2. Similarly, root 3. What is the minimal polynomial to satisfy this one? X square minus 3. What is the what about the degree this one? 2. So 2 is 2. 2 into 2. We are getting the 4. This is a degree. Am I right? This is a splitting field of the given polynomial. This is a degree of the extension. The last one, the fifth problem, very interesting one, the same. They are very simple also. X cube minus 1 equal to 0, x cube equal to 1, x equal to 1 power. We know very well these are all the steps. So here which one is the splitting field? Q of omega, that is W, is here splitting field. The root of x square plus x plus 1, which is the minimal polynomial whose degree is 2. So 2. Am I right? Q of this one is a splitting field, degree is 2. So thanks for watching video. I hope everyone the concept of the splitting field and the degree. So thanks for watching video. For max lovers, please give the comment. Thank you very much. Thanks a lot. Thanks for your cooperation. Always. Thank you. Thank you very much.